Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this video is regarding solving trigonometric equations. And to solve the trigonometric equation, the first question that we have is for question to solve the equations for 0 degrees lesser or equal to x lesser or equal to 360 degrees. So we have to be careful that our angle mode has to be in the degree mode. And the question is for 5 tan of x minus 1, which is equal to 9. Let's start solving the question. So to start solving the question, I can solve for tan of x, and for that I can say it's 5 tan of x, which is equals to 9 plus 1, or it's 5 tan of x, which is equals to 10, or I can say it's tan of x, which is equals to a 10 by 5, or tan of x, which is equals to a 1, which is equals to a 2. So I have the trigonometric equation, which is equals to a 2. So that means I need to solve tan of x, which shall be equal to a positive 2. So as we know that to solve a trigonometric equation, the first thing is to locate the quadrant. Tan of x for positive values, we know that for all positive values of x, locating the quadrant, all the positive values of tan of x, they lie in the first and the third quadrant. So we have located the quadrant here, and here we shall be having the basic angle. So to get the basic angle, I should say that my basic angle then should be equal to tan inverse 2, or tan inverse 2 from the calculator, it comes out to be a 63.43 degrees. So this is 63.43 degrees here, meaning the basic angle is a 63.43. We know the basic angle, it has to be with the x-axis. So this is 63.43 degrees here. And then to solve for the values of x, I need to have the angles, the general angles, that means the complete rotation. So in the first quadrant, obviously it has to be the same, 63.43. And then in the third quadrant, we know that it should be a 180 degree plus a 63.43, or I can say that the x values here are 63.43 degrees and 1. So 180 plus 63.43 gives me a 243.43 degrees, and this then is going to be the answer or the solution for all the values for x, for tan of x, which is equal to 2 here. Let's do another question. Solve the equation for 0 degrees lesser or equal to x lesser or equal to 360 degrees. And the question that we have is for 9 sine x minus 15 degrees, which is equal to a negative 4. So here there is one thing that we should be taking note of, and that is this x minus 15 degrees. So x minus 15 degrees mean that here our domain or the angle value needs to be an x minus 15. Now the domain that is given to us is for 0 to 360 degrees. So first thing is to adjust the domain first. So over here, what I know is that my domain is for 0 lesser or equal to x, which is lesser or equal to 360 degrees, whereas in the question they are saying it should be x minus 15. That means I should be adjusting this negative 15 to the given domain for x, and to do that I will say it's 0 minus 15 degrees. I'm adjusting the domain here, which is x minus 15 degrees, and then to the 360 degrees also I should be adjusting this negative 15 here, meaning now I can see that my domain for x minus 15 is starting from negative 15 lesser or equal to x minus 15, which should be lesser or equal to 345 degrees. So this means that my domain here should be from negative 15 degrees up till 345 degrees here. So negative 300, negative 15 degrees, that means we first should be having this angle. The rotation here should be starting from negative 15 here. Negative 15, that means it's the clockwise rotation. Negative 15 degrees clockwise rotation, and then it should be for positive 345 degrees, meaning this is going to be a 345 degree values here. So instead of 0 to 360 for x minus 15, I can see that my domain value now is from negative 15, starting from this line here, starting from this rotation value here up till 345 degrees. So this is called adjusting the domain. So whenever in the trigonometric equation, it's not an x but a composite value, which is x minus 15, or anything added or multiplied with x, then that means first we have to adjust the domain value here. So we have adjusted the domain, and now the domain is from negative 15 till 345, meaning all the angles that we shall be finding out for x should be uh, for x minus 15 should be between negative 15 till 345 degrees. So let's start solving the question. So to start solving the question, now here I have sine of x minus 15, which then shall be equal to negative 4 by 9, or I can say it's sine of x minus 15, which is equals to a negative 0.444 and 4. Now we have already adjusted the domain. We have sine of x minus 15, which should be equal to negative 0.4444. Let's locate the quadrant for negative sine ratio. So for negative sine ratio, we know that it should be in the third and in the fourth quadrant. Sine is negative in the third quadrant and then in the fourth quadrant. So with respect to the negative sign, we have adjusted the quadrants here, third and the fourth quadrant. Now the next thing is to get the basic angle. So to get the basic angle, simply I'm going to say that it is going to be the basic angle for sine inverse 0.444 and 4. So this basic angle value should come out to be 26.38 degrees. The basic angle value here is coming out to be a 23.39 degrees. So I have the basic angle, which is 23.39 degrees on both the sides, 23.39 degrees, meaning now I can say that x minus 15, I have sine with x minus 15, this shall be equal to, now obviously if I have located the quadrant, then I know that the quadrant values are with respect to the axes, so that it is from 0, 90, 180, and then 360 and 270 here. So what I know is in the third quadrant, I should be having my angle value as 180 plus 23.39, and in the fourth quadrant I should say it's a 360 minus 23.39. So x minus 15 here comes out to be, I can see that over here 180 plus 23.39 is a 206.39, and 360 minus 23.39 is a 336.61 degrees. Now starting from negative 15, I have this basic angle which is a 23.39. So even if I consider a negative 23.39, if I consider a negative 23.39, let's make it here, then I can see that this negative 23.39 23.39 is out of the domain, which was negative 15 up till 345 degrees, negative 15 up till 345 degrees. Therefore, clockwise angle negative 3.39 should not be within the range. Instead, I should say that it's the first anti-clockwise angle in the third quadrant and then in the fourth quadrant here. And I can see that 206.39 and 336.61, they are very well within the domain of negative 15 up till 345 degrees. So I have the two angles with respect to x minus 15, which are confirming or validating the domain that we have found for negative 15 up till 345. So last thing is to find the value of x. And to find the value of x, I should simply be adding this 15 on the other side. It's simple algebra. Take negative 15 on the right side. Therefore, the sign changes for both the angles that we have. So 206 plus 39 plus 15 and 336.61 plus 15 degrees. So the final answer that we shall be having here is going to be a 351.61 degrees and a 221.39 degrees. So 221.39 and 351.61, again they are confirming the x domain, which was from 0 degrees up till 360 degrees. So finally I should round off my answer up to one decimal place for the angle value. It should be a 221.4 degrees and a 351.6 degrees here. So this then is going to be the answer or the solution for the angle value x with respect to 9 sine x minus 15, which is equals to negative 4. So here we have followed 4 steps. Step number one was adjust the domain. Number 2, locate the quadrant. And number 3, find the basic angle. And finally, after that, you have to find the general angle here. So these are the 4 steps that we shall be following whenever we have an equation which is not just for x, but there are some other values of x attached with this x value. So adjust the domain, locate the quadrant, find the basic angle, and then find the general angle. So these are the 4 steps we shall be following now with respect to these kind of equations. So let's do another question. The next question that we have says find all the angles of theta between 0 and 360 degrees. And the first question is for cos of theta by 2. Again, we have the theta by 2. If they are asking for the theta and in the question we have the angle which is a theta by 2, it's a complex angle, then this means first we have to adjust the domain, the given domain for theta, which is for 0 and 360 degrees. So the question is for cos of theta by 2, which is equals to negative 0.379. So let's start solving the question. Cos of theta by 2 equals negative 0.379. So the first step that we need to follow is to adjust the domain. So to adjust the domain, what we see here is that the given domain for theta is for 0 degrees less than theta, which is less than 360 degrees. And in the question, we have the complex domain, which is a theta by 2, meaning I should be dividing this domain with theta. So I should say it's a 0 divided by 2 less than theta by 2, which is less than 360 degrees divided by 2 here. So this means that after adjusting the domain for theta by 2, my domain is from 0 degrees up till 180 degrees. So I have to have all the angles which are within the domain of 0 till 180 degrees for theta by 2. So the first step is done. Let's start with the second step, which is to locate the quadrant. So to locate the quadrant, it says it's cos of theta by 2, which is equals to negative 0.379. And keep in mind that we have to have the angles between 0 and 180 degrees, meaning I have to have the angles between 0 and 180 degrees. Zero, 90 and 180 degrees. And here, because my cosine is a negative, I should say here that the only quadrant that I should be having here is the second quadrant. Now I have located the quadrant. I should not be going beyond 180 degrees because of the adjusted domain for theta by 2. So I have the second quadrant location. Now I need to get the basic angle here. So to get the basic angle, I should say it's my basic angle, which is equals to cos inverse 0.379, and this basic angle, it comes out to be 67.73 degrees. The basic angle comes out to be 67.73 degrees. 67.73 degrees here. And then I need to have the general angle. So for the general angle, I should say it's a theta by 2, which then shall be equal to 180 degrees minus 67.73, which will give me the answer for theta by 2 as 112.27. Or for theta values, so I can see that for theta by 2 I have this angle which is 112.27, and it is in the domain of 0 to 180 degrees. So finally, to get the theta value, I should say it's 2 times 112.27, meaning this 2 here should get multiplied by 112.27, and that gives me the answer as 224.54. And finally I can say that my theta angle, theta value up till 1 decimal place is a 224.5 degrees here. So then this is going to be the answer, the final answer for this question. Part B, it says it's tan of 3 theta, which is equals to 1.988. So tan of 3 theta equals 1.988. Again, I shall be following the 4 steps, and we know the 4 steps they are. So I shall be following the first step, which is to adjust the domain. The domain, the respected domain, is from 0 less than theta, which is less than 360 degrees. And here I have seen that it should be a 3 theta, meaning all the values, they should get multiplied by 3, so that now my new domain is from 0 up till my new domain is from 0 less than 3 theta, which is less than 1080 degrees here. So question is for tan 3 theta, which is equals to 1.988. We are done with the first step. We have adjusted the domain, which is from 0 to 1080 degrees. Now the second step is to locate the quadrant, and to locate the quadrant we should know that it's for tangent positive. So tangent positive, it should be lying in the first and the third quadrant. So first and the third quadrant, this is where the angle should be. Get the basic angle. So to get the basic angle, it should be tan inverse 1.988. So tan inverse 1.988, that gives me the answer. So basic angle is a 63.297 degrees. So 63.297 degrees. I'm taking an exaggerated value. Later I will adjust it to one decimal place. So this is 63.297 degrees. We have the basic angle. Now to get the general angle, we should say that it is a 3 theta, which should be equal to the angle in the first quadrant, which is a 63.297. Then in the second quadrant, it should be 180 plus 63.297. So for 3 theta, what we should know is, what we have found out is that it is from 0 up till 1080 degrees. So we have to go up till all the values which are less than 1080 degrees. And also we should be knowing here that this 3 means that this angle rotation, this trigonometric ratio is going for 3 rotations. 3 theta means 3 rotations. 3 rotations mean that starting from 0, it's the first rotation here, then it's the second rotation, and then third rotation in the same quadrants. So how to get these values? Now let's start working on it. It's 3 theta, which is equals to 63.297, and also it's 180 plus 63.297, which gives me a 243.297 here. Now if I'm saying that we have to go up till the third rotation, then these are the two values which we have in the first rotation. These are the first rotation values, 63.297 and 243.297. Secondly, for the second rotation, what I can say is that it's 63.297 and a 360 added to it, and then 243.297 and a 360 added to it. So these are the two values up till the second rotation. So I have the 3 theta values. Still I can see that we have to go for more angle values here. So I can see that up till now, for the second rotation, I have the angle values as 63.297, 243.297, 423.297, 603.297. That means still we have the margin of the angle rotation up till 1080 degrees. So I can add a 720 to 63.297 for the third rotation. 360 plus 360, that gives me a 720. 243.297 plus 360 and then plus 360, which is a 720. Or I can say that it's a 423.297. To this I can add a 360 degrees over here. So it's your choice whether you want to do it for 63.297 plus 720 degrees for the third rotation, or it's a 423.297 plus 360 for the second rotation. For the third rotation, they will both give you the same answer. So here, if I start working on it, I can say it's a 423.297 plus 360 degrees and a 603.297 plus 360 degrees. So 3 theta values here are then going to be 63.297, 243.297, 423.297 and 603.297 and 423.297 plus 360, that is a 783.297, and 963.297. 297. So these are the 6 angle values which we can have for 3 theta. That means 3 rotations, 6 values, and they are confirming our domain, which was from 0 to 1080 degrees for 3 theta. But the question has asked us to get the theta value. So to do that, I will just adjust it with the 3 by dividing each and every angle that I have by 3 here. I'm just going to adjust the 3. So therefore, each and every angle should get divided by a 3 over here. So now I can see that my theta values are going to be, so after dividing by 3, I have my angle values as a 21.099, 81.099, 141.099, 201.099, 261.099, and 321.099. So my final angle values are going to be 21.1 degrees, 81.1 degrees, 141.1 degree, 201.1 degree, 261.1 degree, and 321.1 degree. So now I can see that all the angle values that I have for theta, they are in the range of 0 till 360 degrees. So this is how such questions for complex angles are done with respect to the 4 steps that we have. Number 1, adjust the domain, locate the quadrant, find the basic angle, and then find the general angle here. So let's do some questions with respect to the radian mode as well. So solve the following equations for 0 lesser or equal to x lesser or equal to 2 pi. So these angles, obviously I can see that from 0 to 2 pi, my calculator should be in the radian mode, meaning I should be solving all my questions with respect to the radian mode. So let's start solving the first question. It says it's 6 cos of 3x minus 3, which is equals to 0. So let's first solve or adjust for the domain. So actually it's given for x value, which is from 0 till 2 pi. And here I can see that my angle is at 3x. So I will be adjusting it with this 3. So I can say it's a 3 times 0 lesser or equal to 3x, which is lesser or equals to 3 times 2 pi. Or I can say that my domain for 3x should be starting from 0 radian up till 3x and then 6 pi here. So 6 pi again means that I should be going up till 3 rotations. So let's start solving the question now. So here this becomes 6 cos of 3x, which shall be equal to 3. Or I can say it's cos of 3x, which is equals to 3 divided by 6. Or I can say it's cos of 3x, which is equals to a 1 by 2. I have solved the equation with respect to the cosine ratio, and cos of 3x is equal to a 1 by 2 here. Now first step, second step, we have adjusted the domain. Now the second step is to locate the quadrant. Cosine here is a positive, therefore I should say that my quadrant should be in the first and the fourth quadrant, as my cosine is positive in the first and the fourth quadrant here. After locating the quadrant, get the basic angle, and to get the basic angle I should say it's cos inverse 1 by 2 and cos inverse 1 by 2 in the radian mode. So cos inverse pi by 2 in the radian mode comes out to be pi by 3 here. Let's keep it in terms of pi, because pi by 3 is a definite angle that we should be knowing. Pi by 3 in degree mode equals to 60 degrees. So I have a pi by 3 here and a pi by 3 in the fourth quadrant as my basic angle. So to getting the basic angle, I should be having 3x general angle values, and in the first quadrant I can see it's just a pi by 3, and for the fourth quadrant I should say it's a 2 pi minus pi by 3. So 3x then shall be equal to a pi by 3, and then 2 pi minus pi by 3 is a 5 pi by 3 here. As it's a 3x, we have already adjusted the domain, which was from 0 till 6 pi. I know here that 3x value, then for this 3x value I should be adding the general angles for the second rotation. Second rotation means to all the two first rotation general angles I should be adding a 2 pi here. So pi by 3 plus 2 pi and 5 pi by 3 plus 2 pi. This is my second rotation value. So 3x then will be equal to a pi by 3, 5 pi by 3, 7 pi by 3, and solve this question, it should be an 11 pi by 3. Now for the third rotation, to 7 pi by 3 and 11 pi by 3, add a 2 pi. Give them a complete rotation again. 7 pi by 3 plus 2 pi, 11 pi by 3 plus 2 pi. Therefore, my 3x values here are a pi by 3, 5 pi by 3, 7 pi by 3, 11 pi by 3, and here 7 pi by 3 plus 2 pi, that will give me a 13 pi by 3, 13 pi by 3, and 11 pi by 3 plus 2 pi, that should give me a 17 pi by 3. Now here again I should be getting rid of this 3 to get all the x values. Therefore I should say that my x then shall be equal to pi divided by 3 times 3, which is a 9, and then 5 pi by 9, and then 7 pi by 9, and 11 pi by 9, and 13 pi by 9, and then finally it's a 17 pi by 9 here. So this is then going to be the answer for these x values for this trigonometric equation that we have had here.